Okay, now I'm gonna solve couple exercises using the critical value approach. One is for testing the proportion. A factory claims that less than 8% of its items are defective, a quality control. So how would you write the null in the alternative hypothesis here? Less than, it's in the alternative hypothesis, so P will be less than 0.08, the claim. The null hypothesis will be greater than or equal, because this is the complement of less. But if you are taking my section online, you should put only the equal sign in the null hypothesis. So for section 9899 will be P equals 0.08, and then the alternative will be P less than 0.08. A random sample of 200, so N is 200, and find that 10 of them are defective. This is the number of successes, X. Test the claim at alpha equal 5% using critical value approach. So we're gonna use a static crunch for this, and let me show you how we proceed. So we're gonna go to stat, proportion stats, one sample with summary. I will reduce this so you can see. Number of successes is 10. Number of observations is 200. We're testing against 0.08. So even the critical value approach, guys, you can still use StatCrunch. I'm going to show you how to do that. Although you could use the p-value approach, but I'm just showing you this method as well. P less than 0.08, this is the alternative. And want to show the critical value, that's very important. And you make sure that you got the right significance level here, which is 0.05. So we're going to compute, remove this inside. So the test statistic is negative 1.56, and the critical value is negative 1.645. So, and look, we got the p-value, but we're not going to use the p-value. But you can tell from the p-value here, guys, that this is bigger than 5%, so we're going to fail to reject HO. And if you use the critical value approach, you're going to fail to reject HO. And let me show you how. So, the test statistic turned out to be negative 1.56, and the critical value is negative 1.645. This is the critical value right here. You put it, just under the normal curve, the standard normal curve. This is and the red, negative 1.645. Since this is a left tail test, you shade to the left of it, of the critical value, and this is the rejection region. But my test statistic is negative 1.56, which is right here, guys, in the blue. It doesn't fall in the rejection region, then in this case, you don't reject the null hypothesis. So if you have a left tail test, if the test statistics is below the critical value, you reject HO. And if it is above the critical value, you fail to reject HO. And you notice, just that negative 1.56 is bigger than negative 1.645. That's why you fail to reject HO. So Z is negative 1.56. We use StatCrunch. When alpha is 0.05, the critical number is negative 1.645. We use StatCrunch. And since the test statistic is bigger than the critical number, we fail to reject the null hypothesis. And then the conclusion will be, if we fail to reject the null hypothesis right here, we cannot support the claim. So we say there is not enough evidence at the 5% level of significance to support the claim that fewer than 8% of the items are defective. If you were to use the p-value approach, guys, you don't need the critical value, and you notice the p-value was bigger than 5%, you fail to reject HO as well.